Hello everybody, this is the video clip for chapter 3 and we are still working on several examples on curve sketching, okay, using the information from your f prime and f double prime. So for this one, our function given in terms of logarithm of 4 minus x squared. So what is the domain of a logarithm? If you can still recall, okay, a log of a box, okay, will be valid whenever your box is strictly positive. So it means that right now this one is your box, okay, 4 minus x squared. So it means that for this problem your 4 minus x squared must be strictly positive, okay. It is the same as x squared minus 4 strictly negative, right? And it will be the same as x minus 2 and then x plus 2 less than 0, okay. So it means that you are going to range between negative 2 and 2, and then you need a negative interval, so it will be around here, right? Okay, so it means that the domain will consist of the open interval, okay, from negative 2 to 2, okay. So what will be the x-intercept? For the x-intercept, we are going to again let your y equals to 0 or your fx equals to 0 and solve for this one, right? So it is going to be what? So this one will be e, right? Okay, so it will be e raised to the power 0, which is 1, equals to 4 minus x squared. So it means that your x squared equals to what? To 3. So it means that the x-intercept will be either plus or minus square root of 3. So here it will be negative square root of 3 and positive square root of 3. For the y-intercept, you are going to let your x equals to 0 and you have log of 4, okay. And you may use your calculator to calculate a little bit that your log of 4 is approximately 1.39, okay. What will be your horizontal asymptote? For the horizontal asymptote, you are going to let your x becomes either positive infinity or negative infinity, right? Okay. However, because of x squared, either positive or negative infinity, after you take a square, it becomes an infinity again, right? So it will be a log of 4 minus infinity, roughly speaking. So 4 minus infinity will be log of negative infinity, right? Oh, by the way, this is very absurd. Why is that? Because here your x can be ranged from negative 2 to 2. So your x cannot go beyond those, interval, right? So your x cannot go to either positive or negative infinity. So of course there will be no horizontal asymptote, right? Okay, sorry about that. However, for vertical asymptote, okay, actually we are going to need to find like at which number, okay, of x in again inside this interval, right, that your function goes to either positive or negative infinity. So actually it will be like something that involve the endpoint of this interval, okay. Why is that? Because actually we got two kind of infinity for the logarithm. Remember, the log will go like this, right? Okay, the log of x, okay, will go like this. So it means that the log of infinity will goes to infinity, and the log as you go close to 0 on the right, it will goes to negative infinity, right? Okay, and as we told you that this one, your this thing inside cannot goes to infinity, is it? Otherwise your x must be pretty large, but your x is kept between negative 2 and 2. So it means that another way is that your thing inside here may be approach 0, okay. And of course it can happen, right, when your x go either close to negative 2 or 2, your x squared becomes a 4 and it will be close to 0 on the right, okay. So it means that for a vertical asymptote, it can be x at -2 and x at 2. Okay, and if you really take a look, it will goes to what? It will goes to the either way will goes to negative infinity, because as we told you that it becomes a roughly speaking log of 0, okay, which will goes to negative infinity. We get now for a derivative, okay, a derivative of the log will be 1 over 4 minus x squared, and then a derivative of the inside, okay, multiply, which is negative 2x, okay. So here we got negative 2x, and then 4 minus x squared. So I'll just get rid of that negative, so it becomes 2x over x squared minus 4, okay, or it is 2x and then x minus 2 and x plus 2. Are we all right? Okay. However, because right now our domain under consideration is kept from -2 to 2, so we are not going to take care of something outside, okay. Everything must be inside this open interval, okay. So the only thing that may happen is that again you may need to consider that all this one will exist, right, for each and every x in the domain under consideration from -2 to 2, right, because we don't care about the endpoint, okay, we just get rid of it already. So the only thing that can happen as your critical value, it will be the one that make your derivative equals to 0. We good. And if your derivative equals to 0, it means that your top only, right, equals to 0. So it means your x equals to 0. Okay. So again, we are not going to consider anything outside. All right. Okay. So let me just erase the one outside because we don't need it. Okay. So here you can just plug in like either, for example, you can use 1, okay, and then plug in here. So you have a positive, you have a negative, you have positive. So altogether it becomes a negative, right? And then you can use -1. So you plug in here, you have positive, negative, and then negative. So altogether it becomes positive. All right. So it means that the critical number of this function will be a 0, okay, alone. And then it will be increasing from -2 to 0, right? So the interval that you are the side of your f prime is positive, and then it will be decreasing on the interval that the side of your f prime is negative, okay. And this one you already determined that it is going up and then going down, right? So you have a hill, you see, you got a hill, right? So it means that you have a local maximum but no local minimum, okay. So a local maximum, it will be at the point when your x is 0 and your y it's just simply log of 4. We get. And then a local minimum, you have none. All right. So how about your f double prime, so that we can consider the concavity for the f double prime? So let's see what is it that we have. We can continue from here, right? The this is your f prime, right, using the quotient rule. So it will be a bottom derivative of the top minus what, the top, which is what, 2x, derivative of the bottom over your bottom square, okay. So here we have 2x square minus 8, and then minus 4x square over this whole thing square. So it means that you got negative 2x square minus 8 over x square minus 4, and then square again. So you can pull out a common factor, which is -2, right? And then you have x square plus 4 over x square minus 4 square, okay. So look at it carefully. The square here So it means that everything will be positive, right? Because again, we are considering in this interval, right? So your bottom cannot be 0, but with the square, everything will be positive. This one as well, a square and then plus 4, everything will be positive. But with this one, okay, a negative there, so it means that for each and every value of x inside those interval, okay, so this one for each and every x from negative 2 to 2, your f double prime always negative, okay, no change of the side of your f double prime. So what does this mean? So it will concave downward all the way, okay, so it concave downward from negative 2 to 2, and there's no interval that the concavity is upward. So if it keep going downward, I mean the concavity, so it means that we have no inflection points, right? We have no inflection points. So here, all what you need is from negative 2 to 2, right? Right? Because that's the interval under consideration, okay, from negative 2 to 2. So let me do it here. Negative 2 to 2, and then you have a 0 here, okay. So beyond 0 we have decreasing, okay, and always concave down. So it is decreasing, concave down, and before 0 we got increasing and concave down, okay. So here we have the x and the y axis, okay, and then upon this one you have x equals to negative 2, you have x equals to 2, and then at 0 you have the log of 2, right? Log of 4, okay, okay, and it is cutting your x at square root of 3 and negative square root of 3, so somewhere here, okay, square root of 3, negative square root of 3. All right, so your curve, because it is increasing concave down, it look like that, decreasing concave down, it look like this, okay, so it will be something like this, okay, okay, this one has no corner, it must be smooth, all right, and it go close to this vertical asymptotes, okay, or these two vertical asymptotes. All right, okay, this is a graph of that logarithm. How about this one? This is x squared over a square root of x plus 3, okay. Then what is the domain of a function f, okay? On top there's no restriction, right? But don't forget that on the bottom your bottom must be what? Your bottom must be non-zero, right? And the one inside the square root must be non-negative. So altogether it means that your x plus 3 must be strictly positive, is it? So it means that your x must be greater than negative 3. So a domain is from negative 3 onward to infinity, okay. Your x-intercept, you are going to let your y equals to 0. If your y is 0, then again only the top that will equals to 0. So you intercept the x-axis at x equals to 0. And if your x is 0, okay, everything collapsed, okay. So this one also the y-intercept, okay. So it means that your graph will passing through the origin, okay. What is the horizontal asymptote? Where's the horizontal asymptote? You can say roughly, okay, speaking, the if your x goes to infinity, and this one you cannot go to negative infinity, okay, so your x cannot go to negative infinity because of the domain, okay. However, your x can goes to infinity, a positive one, okay. So what it will look like, okay, if it goes to infinity, this one will, roughly speaking, okay, infinity square over a square root of infinity. So which one win? The top win, right? so it will goes to infinity. So this means that we have no horizontal asymptote. Okay, however, you may do a DIY by yourself, okay, to find a limit of this one using the knowledge from chapter 1. Remember, you flip it and then you see that, okay, the limit of the reciprocal equals to 0, and then what else? All right, so actually this one will goes to positive infinity. Okay, so there will be no horizontal asymptote. However, a vertical asymptote, okay, it will be something that involves this domain, all right, and it is at -3, right, that make your bottom equals to 0. So it will be x equals to -3, and this one, as your x go close to -3, okay, on the right, okay, the function will goes to what? Positive infinity, right? So this one you need to again to check why is that this thing happen. Okay, but you can say roughly, hey, I mean on the top is positive, right, x squared, on the bottom is a square root, so it must be all positive. Okay, so it means that from, you know, this one is -3, right, this is 0. So each and everything, I mean all the function that consider, it will be positive all the way, right, cannot go below the y-axis. Okay, because this one, I mean the whole thing, x squared over a square root, okay, must be non-negative. Okay, so how about the derivative? Okay, this is something that may a little bit difficult. Okay, so a derivative will be the top using a quotient, right? A derivative of the bottom. Oh, sorry. Bottom. Okay, derivative of the top minus the top. Okay, derivative of the bottom over your bottom square over your bottom square. All right, so you need to use the cross multiply a little bit. So we have what, 4x and then x plus 3, right, because a square root multiply a square root become just x plus 3, is it, and then minus x square, okay, over 2 square root of x plus 3 and then x plus 3. Okay, because this square is already take care of that square root. Are we okay? So here, let me move it a little bit closer. Okay, so over here we have 4x squared and 12x minus x squared, right? So you have 3x squared plus 12x squared, is it? Okay, okay, 12x, just like that. Okay, then you are going to pull out the 3x, so we have x and 4, and then here you have this one. Okay, don't forget again that right now we consider only the thing from -3 to infinity. Okay, this is our domain under consideration, right? So the derivative here will exist again for each and every x in this interval, right? Right, open -3 to infinity. Okay, so the critical number that will happen, it will occur when your derivative equals to 0. So if your derivative equals to 0, so it means that your x must be 0 and your x must be -4, but -4 is out of the league, right? So only 0 will survive. Okay, so here if you plug in 1, everything must be positive, right? So here's positive. If you plug in -1, okay, everything is positive except this one will be negative. So here's a negative, right? Okay, so it means that the critical number is only 0, okay, when your x equals to 0, and it is increasing. Okay, sorry, this one, it is increasing from -3 to increasing, right? So your derivative must be positive, so from 0 onward, and then decreasing from -3 to 0. And do we have a local max? This one's going down and then going up, so we have a valley. So we have no local max, but we got a local mean when your x is 0, and if your x is 0 immediately, this one will becomes what? 0. Okay, all right. And then for concavity, you need to find your f double prime. So let us continue our f double prime over here. Okay, let me simplify our f prime first. Okay, the f prime can be written as 3x squared plus 12x over 2, and then x plus 3 raised to the power 3 over 2. So it means that your f double prime, okay, it will be the bottom derivative of the top, okay, minus the top derivative of the bottom, which is this one, and right, okay, and then derivative of the inside over your bottom square. So we got 4, and then x plus 3 cube, right, a square. Okay, so now can we simplify a little bit? Can you see some of the common factor? Here is one of them, right? X plus 3 raised to the power 1/2. Okay, the 2 here, the 2 there already cancelled. Okay, we got also a 3 in here and a 3 here, right? Okay, so and that's it, I guess. So let's see, we have x plus 3 raised to the power 1/2, and then what else that we still have it there, a square root, a 2, and then a square root of, no, not a square root, sorry, because you take a 1/2 out, so only x plus 3, and you already take a 3 out, so you have 2x plus 4, right? Okay, and then minus 3x squared plus 12x, okay, the 3 is already out, over 4, and then x plus 3 cube. Okay, so here I mean, you can do it either way. Okay, you can have several ways to do. So for example, you may think that, hey, this one is 2x plus 6, right, and then 2x plus 4. Okay, so altogether will be 4x squared, and then 24, right, and then this one, it is like 12 and 8, right, so 20. Is it 20x? So altogether with the one here, we have x plus 3 raised to the power 1/2. You got x squared, because you have this one together with that subtraction, right? And then subtract by 12, you have 8x and 24, and then over 4 and x plus 3 cube. Okay, so can we do a factorization here? So this one, it is actually what, x squared minus 8x, and then this is 2 and 4, right, and then 16, and another what, another 8, right, is it, or you can say that it is x minus 4 square and then plus 8, is it? Okay, so it means that we have this one always positive, right? Strictly positive. Okay, and a square root must be positive, and this one, because your x is greater than 3, so this value x plus 3 also strictly positive. Okay, so what does this mean? It means that your f double prime here, your f double prime, this one is still your f double prime. Okay, it is strictly positive all the way, is it? Can you see? Okay, so here we have this one. All right, so what does this mean? It's always concave up, right? Okay, for each and every x from -3 to infinity. So here it always concave upward. Okay, and we have no concave, we have no place that it concave down, so it means that you don't have any inflection points, right? So now use all these guidelines to sketch the graph. Okay, so this is not that difficult, and this one should be enough for you to draw it. Okay, because what you only need is from 0, right? And then you know that beyond 0 it is increasing but always concave up, and this one is decreasing and always concave up. Okay, so it means that if you really want to draw it, okay, here at -3, okay, x equals to -3 here, and it must passing through this point, right? And because decreasing and concave up, so it look like this. Increasing concave up, it look like that. Okay, and it must hit this one. Okay, so it go like this, right? And as you approach infinity, your function goes to positive infinity, right? So it go that way. As you approach -3 on the right, your function goes to positive infinity as well. Okay, so we hope that throughout these 6 examples you may see some of the problem, and you already maybe follow the work that we work together. However, in order for you to can be able to do it by yourself, you must do the exercise 4.5 from number 1 to 51, but you can just choose the odd problem to do. Okay, so let's try it by yourself to see like how difficult you are going to considering the f prime, f double prime, and then all the increasing interval, inflection points, and all that kind of thing. Okay, so we'll stop the video clip right now, and it is a good news that this one is the last video clip for your chapter 3. So we'll see you in class. Bye bye.